Hi, I'm Josh Wickersham, and today we have from Dayton Audio Brian Myers, and he is a project manager, and we're going to learn all about the DATS LA, which is a new speaker measurement system. So welcome, Brian. Thank you for coming.
Thank you for having me.
All right, so tell us, what is the DATS LA?
The DATS LA derives parameters of loudspeaker, small and large parameters. It's the predecessor to that is the DATS V3. It was strictly a small signal parameter device.
So you're talking about the teal small parameters.
Teal small parameters, yeah.
Before DATS, how were teal small parameters? How would you even get those?
Well, you would get it, with an amplifier and a resistor, and before the DATS V3, there's other way with various equipment was used, and it's kind of a tedious way of getting it. When the DATS system came out, it made deriving small signal parameters quite easy, in just a few seconds.
Just real seamless. Yeah. Before it was like a lot of arithmetic.
Yeah, it does all that for you.
Okay. So you mentioned the DATS V3, but let's stay on the DATS LA. So the LA stands for loudspeaker analyzer, right?
That is correct.
Okay. So what are some of the, maybe just the teal small parameters in case people don't know what those are?
Yeah, those are all the technical specifications of a driver that can be used to build a box and matching drivers up with other drivers. When I say like matching tweeters or matching mid-ranges or woofers, and also for box design. Teal small parameters are used for that, box design. The DATS LA also, like I mentioned, does large signal parameters, and that's the beauty of the DATS LA. It has a built-in 100-watt amplifier that allows you to do large signal identification or large signal parameters. This is needed in today's, with the high-powered speakers and such that everyone has.
Well, let's jump. We mentioned the DATS V3 and the DATS LA, and some people might be confused what one does versus the other. But maybe just can you list off all the things that the DATS LA does that maybe the DATS V3 doesn't do?
Yes, the DATS LA allows you to first of all do large signal parameters. That's the big one, and also it allows you to do symmetry of BL symmetry, KMS, virtually all your parameters over excursion. This is very useful. BL symmetry for driver design or matching drivers is critical to driver design, is BL symmetry, KMS symmetry, and virtually all the parameters can be viewed in graphs with the DATS LA over excursion.
In the software.
Yeah, in the software.
So tell me what is BL symmetry?
BL symmetry is a magnetic field strength that's applied to the driver when it goes out and when it goes in. So what you want to do is not have it asymmetric, means you don't want it pulling harder as it goes in than out, or out then in, or vice versa.
Right.
And what you want to do, if it's, let's say it's 8 millimeters out and 10 millimeters in.
You're talking about the travel.
Yeah, the travel before it hits a certain mark on BL, your BL symmetry. Then you're asymmetric. You're 8 out, you're 10 in. Well, you could be 9. Your weakest link is your 8 millimeters. So that would be virtually your X max according to BL.
Oh, okay.
It would be 8. But as a driver designer, you would do some modifications to the driver, and that would end up being 9 and 9 both ways. 10 and 8 would be 9 and 9. So you gain just by that a little modification on the driver before it's designed, you could gain a millimeter in X max. It's really critical.
So and as far as I understand, the magnetic field for it's like a donut that's 360 degrees. Like that's the motor structure, and what you're talking about is the voice coil winding.
Yes.
Centering that in that magnetic field. Is that correct?
Yes.
Okay.
When voltage goes through a voice coil, it develops an alternating current and a magnetic field, and and which, with that being said, with a fixed magnet, then it moves according to the AC input.
So in that scenario, you said you make adjustments. What adjustments would you make in that situation?
You could extend the pull piece. You could add you could do some other things. You can move the actual placement of the voice coil on the former.
So the winding on
where
it's actually
you can
placed.
move it slightly up or down.
Yeah.
That's doable. Increase the pull piece. You could do some other magnet changes to increase BL. You could change the magnet if you didn't. If you want to be flatter, you can make like a dual gap or a dual winding to make it flatter for longer on your BL symmetry.
Right.
Which is, all these designs have been out there, and that's what they use, is what they're looking at is BL symmetry. How long you can stay at what excursion, because as you push more air, as you play lower, you have to push more air, and as you play louder, you have to push more air. So it's all about how many millimeters you can push air, the volume of air you can push.
A millimeter makes a big difference.
Yeah, a millimeter can make a difference, yeah.
Tell me about KMS symmetry. What's that?
KMS symmetry is the symmetry or asymmetry of the suspension. And the suspension is typically your spider, your damper, and your surround. And about 85% of it's been known to come from really your damper or your spiders.
Right.
And those can be a progressive spider. You can do some changes to your spider to improve that. It's not as easy as BL symmetry as a driver designer, but it can be done, and it's very useful information.
And that you say you found an asymmetry in the KMS graphs in the DATS LA software. Maybe some changes you could make is maybe the compliancy of that spider.
Yes. Or you can make
like
it. You could change the position of the dampers or spiders, and because it may tighten up different as it goes out, it may tighten up sooner than when it goes in. So you could either change to a different damper or a progressive damper, progressive spider, and do some changes like that. But that's typically more trial and error than BL symmetry.
Okay.
But there is many spiders out there that you could use in the industry.
So a lot of this use is really for for people who are really designing drivers, designing woofers.
And I've been designing drivers for Dayton Audio for 15, 17 years now, or something like that. And it's been I always looked at what we call Clipple system.
Yeah.
And that is a very nice system. It gives you a lot of information about the driver. And I used to use that, and that's what prompted me to come up with something that was more suitable for the DIY or the serious DIY or the audiophile that wants to match up speakers or small OEMs that develop speakers and the larger industry as a whole. So,
and that was going to be a question is going back to the DATS V3 for 1 second, like you would. Like the DATS V3, like you could design a box off of a spec sheet, but you don't know if that driver is actually hitting those specs. That's just the published.
Yeah, and what
specs.
You'll find out with the DATS V3, that was something, and the DATS whole progression of the DATS system, starting with the woofer tester. For many years, it revealed some of the inconsistent parameters listed by certain manufacturers, or just you get a bad driver. You need to know what that driver is in your hand. The one you have in your hand,
right? You
want to define the parameters of that driver.
And you said like the DATS V3, for verification against the spec sheet. The DATS LA, this is just basically understanding the, maybe limitations or what the driver's capable of.
It reveals even more.
Right.
When you have the BL symmetry and the KMS symmetry, you can look at the potential of the speaker, the total potential. Teal small parameters gave you some basic stuff at low to medium power, but when you start giving a speaker in the nonlinear mode, and you start pushing a speaker in the nonlinear mode by giving it more power, then the DATS LA would reveal certain parameters, why something is not doing as well as you thought, and what improvements might need to be made.
Right. So if someone has had a DATS V3 for years, which that's been available for years, you said that the DATS LA reveals even more. And so that would, I guess that would be a reason for someone to pick up the DATS LA, is if they're really serious about speaker building, or even engineers out there that are designing. This is something that, it's just deeper insight into that particular driver that they're holding in the hands.
Yes, it is. It's much deeper. For instance, in the last 4 years and 4.5 years of developing this product, I have learned more about loudspeaker behavior and the way parameters change due to power input and due to excursion, the way they change, than I have in my 30 years prior.
Just in developing
this. I see things all the time, every day, and I thought I was pretty well versed, but boy, this will reveal a lot that you said, oh, that makes sense,
Right.
But I never knew it happened that way. So it's very interesting.
Very
good learning tool.
Give me an example of, are there, what are some of the things that you've kind of learned?
Right. Well, you can kind of see how, of course, when you give a speaker more power, your resistance, or your RE, your resistance, your voice coil go up because due to heating. Mm-hmm. And when that happens, it actually changes your BL and your symmetry somewhat of your BL, and it changes your parameters.
When the voice coil heats.
And, with small signal, about a watt, or about a volt or so input, you really don't see that. But as you increase voltage to 1 to 5 to 10 volt, you can see how parameters are constantly changing at every voltage.
And that's kind of like a real world scenario, because as a woofer's moving, that voice coil's getting, it's getting electric energy the whole time.
Would be the voice coil would probably be warm in some instances. Now, it only takes, it doesn't take long for the voice coil to cool. That's where aluminum formers, something to wick away the heat.
The venting.
That's what and venting and all that come into play. But it will be warmer than at rest, without. And when that changes, and when you do a small signal parameter list, RE will be at rest. It's just a small signal, it never heated up. And what the beauty of the DATS LA is, it gives you the ability to, in between sweeps, it can be delayed up to like 600 seconds. So if you want it to completely cool down before your next sweep, and what it does a DC biasing.
Right. Yeah. So actually, you're getting. I got a little list of questions here, but you're getting ahead. So let's actually. I want to actually know. Let's see here. Like, how does it work? It has a patent, right?
Right. It does have patent.
And you're named on the patent?
Yes.
And then another gentleman?
Yes, John Murphy.
Okay. We'll get into him in a second. But just tell me. Like, I just got a DATS LA. I plugged. Tell me the experience. How does it work? How do you use it?
Okay. First, you just do some simple calibrations. That's all it is. You plug it in via USB, and it works with hardware, software, just like the DATS V3. It's real similar to DATS V3 for the tens of thousands of people who already have that out there. Mm-hmm. The software is very similar. You'll get started in the same fashion. But what it does is allows you to take those parameters, the teal small parameters or large signal parameters, and import them into symmetry mode. And what you do there, you pick out your maximum voltage and how many sweeps you want to do in each direction. Okay. And what it does, it DC biases the driver and then runs a small signal sweep or a larger signal sweep. You can also pick the level of your sweep out.
Like how many volts are going into that sweep?
Yeah, how many volts. Okay. And what you can do is also you can print out when you're all done, and you get this symmetry graph of all your parameters over X, over excursion. And the important ones again are BL and KMS, but you get that. You can also print it out in a table and and look at how RE changed, how everything, all the parameters are changing and how they change with heating of the voice coil. You can set your delay for more time between sweeps, so your voice coil is not heating up so much.
So you said that a couple times. Sweep. How many? So just so I'm following. The voice coil is at rest, and you say DC bias. So the DC is gonna engage that permanent magnetic field, and it's going to rise the voice coil up in the magnetic gap, and while it's in that DC bias state, it runs a sweep. Is that right?
Yeah, it has a 2-second DC biasing with a 0.7 second sweep.
I see.
A normal sweep.
20 to 20K.
Right,
Yeah.
and that's how it derives its parameters from each biasing, and each time it increases its level. And
You mean the
on
DC
end,
biasing?
Yes.
So he's
On
going to
the
go
out,
up.
and then it's going to stop, and that's going to go down.
So it's going to it's running sweeps on the invert and on the out.
And that's what will give you your symmetry graph.
Got it.
Yes, and so it's it's really accurate. It's above all, it's affordable.
Yeah.
And
It's not as expensive as Klippel. That's for sure. Okay, so you're one of the inventors. John Murphy's the other inventor. Who came up with the idea?
Well, I wasn't the first in the industry to think DC biasing. I mean, I think it was even 15 years ago I was thinking, well, let me just DC bias a speaker and run a sweep. It sounded simple, but you can burn up a lot of drivers, and it's hard to get an amplifier that can do both.
Yeah.
That's the beauty of this amplifier. It can DC and then run AC sweep. So it has two channels it works with, right?
Yeah.
And pretty unique. Who designed that was John Murphy. He's a physicist, audio engineer, pretty well known in the industry.
Yeah.
And he has some software on his own. And he's the inventor of our DATS system, or back in the our woofer tester back in the day.
Did he do the software too?
Yes, he did the software. And so I called him one day, and this has been about 15 years ago, and he was busy, and he's still working for pretty top secret stuff, I guess.
Sure, yeah,
and he didn't want to tell me, but he didn't have the time to do it. And I kept asking about every 6 months, keeping in touch, because he already had this product for us, this DATS V3, and it's selling well. So I keep him abreast on improvements on the DATS V3 and everything. But I kept asking about this, and finally he retired, and he said, that just might work. And that was about almost 5 years ago. And he'd been working it and perfecting it, and now it turned out to be something, again, I learned more about in the last 4 years about driver behavior than I did in my previous 30 years of thinking about.
So you and John, you had 5 years of development for the DATS LA.
Yeah.
Wow. That's impressive.
It wasn't an easy task. And mostly for him, I have to give him credit. He's a genius behind this thing.
Yeah. Well, yeah, that takes a lot of brain power to. I mean, and he did the hardware too, right? He laid out the hardware.
And laid out the hardware,
software, and so together. So this was, I think. Correct me if I'm wrong. Was there a system like this that used a vacuum?
Yeah, well, I've been informed that the DUMAX system, before that, the engineer or the inventor of the DUMAX system was trying to DC bias drivers and get it. And then he ended up using what's called a DUMAX system, which uses a vacuum to
bring the coil out of that gap,
to
not
actually suck the driver in and in both directions.
Did it work?
It did work. It was expensive and laborious process, I heard. I haven't used it. I've been using and looking at Klippel for Klippel's the other way, and they use a laser.
Yeah.
And they just use, I believe, large sweeps and certain tones to do it. But it's quite expensive and a laborious process as well. This can be done as quick as you want to do it. Within a couple minutes, you can get some basic parameters, do only 4 sweeps each direction, or you can do up to 9 sweeps each direction, and then get a little bit more details in your graphs.
So how, you mentioned Klippel, how does it compare to Klippel?
Well, Klippel, it's using a laser, and we have compared the DATS LA with the laser, and we're about 0.2 millimeter, plus or minus 0.2 millimeter. We're getting there to the actual laser. We compare it with the laser. And we're trying to, dial that in. John is trying to dial that in every day to get it better and better and better. Yeah. But we only use an equation.
Right.
We use a mathematical equations, and he's a genius behind it.
You're talking about calculus now, so I'm out.
Yeah, and so it is an excellent product for learning tool.
how do you know that the DATS LA is like pretty like it, how do you know that the DATS LA is comparative to the results you would get from Klippel?
Well, I have plenty of drivers that I had Klippeled, and I sent John
Specific
4
drivers.
or 5 drivers that I had Klippeled.
So-
Right.
so
I call it Klippeled, but
Right,
had
yeah.
Klippel analysis done.
So you took one driver, and then you had Klippel data on that driver, and then sent it to John. John's running it on in the development, running it on DATS LA, and what was the result?
Well, that's what gave us the, tweaking of the equation for him. And it wasn't just one driver, it was many drivers.
Yeah.
And I've done many drivers and compared my Klippel LSI
I see.
analysis against what we're getting with our BL symmetry and our BL, equation. I'm sorry, our BL number, if it's 7 Tesla meter, see if we're right there and see how the shape of the curve ends up being exactly like, the Klippel LSI.
So on those specific drivers, you measured it on a Klippel testing system, and then you have the results, and then you measured it on DATS LA, and you're saying it was.
Yeah, that's how we got.
It was close.
It took 4.5 years. Very, very, very close.
That's
yeah.
nice.
Now, if you want precision down to the hundredth of a millimeter.
Yeah. Well, they're using lasers.
Yeah, and it gets you that, but I can tell you a hundredth of a millimeter means nothing in the scheme of things when you're talking about
Especially
a loudspeaker.
real world application. Yeah.
Yeah.
All right. Let's see here. Let's see if I have any other questions. Tell me the difference between. No, it's kind of confusing every time I say this. It's teal small, small signal parameters and large signal parameters, right?
Yeah.
So explain the difference between small signal parameters and large signal parameters.
Okay. Typically, small signal parameters are typically in the past been about 1 watt input, where they test a speaker and measure a speaker. That's why you'll see 1 watt at 1 meter away on a lot of testing. And also, a lot of the small, teal and small are two audio engineers in the business that come up with these parameters. Large and signal are the same parameters. They're still teal small parameters.
Yeah.
But they're in large signal or small signal domain. And large signal is typically when you get it beyond where it becomes nonlinear. And it depends on the driver, how far you're pushing the driver
Right.
before it comes nonlinear. Of course, a smaller driver will take less voltage input, become nonlinear than a larger driver.
So to understand it, you're saying you're pushing to that driver kind of to the cusp of where it starts to become a little nonlinear. And then you're getting the parameters at that level.
Yes.
Right. So and that's again a little bit more real world, especially for higher power situations.
Yeah, and when teal's small in the 60s and possibly even before that when they first come out, 1 watt meant something.
Yeah.
1 watt was significant. When you had a
Efficiency was
speaker at
everything.
94 dB at 1 watt, they had these small magnets, but it was something back then.
Yeah.
Is it relevant now? It's relevant. You can build your box around 1 watt and your small signal input, but in reality, for real world, you would want real world specifications.
You want, yeah, and you said, I think earlier you said it has 100 watts built into the DATS LA.
Yes.
So you can feed 100 watts into a driver and then derive those more real world parameters and then build your box off of those parameters rather than the small parameters.
Correct.
Right.
And not only building boxes, but pick out your best 2 drivers. Let's say you want a home theater and you bought 7 drivers.
Yeah.
And your front 2, though, if you play stereo, you want your front 2 to be the best.
Okay. Yeah. Right.
So you would pick out the best 2 out of those. That's what I'd use it for.
Or even just maybe like match pair type of things.
Yeah,
If, you
could match your pair, right? And let the others that are just off a little bit, let them for the back, rear, surround. It doesn't where it doesn't mean as much as a stereo pair. So that's how I'd use it as an audio file, you know, but as a driver designer, there's nothing else out there. I think every audio driver designer needs one.
Well, I know, I mean, I've met a lot of speaker builders, and I know that they really want details. They want, and if there's a bridge further for, you know, getting more details, it sounds like maybe the DATS LA is for them.
Yeah, I think so. I think it's well worth, you know, every penny, and it also is a wealth of information that even the most seasoned driver designer could learn many things off this. I mean,
like you said, you did.
Yeah.
I mean, is it almost like like you were kind of questioning some of the philosophical things that you used to know?
Yeah, I would see something change. I say, well, why is that? Oh, yeah, well, KMS, it's tightening up as it goes out, so KMS would go low, you know. And you start figuring out, it starts making sense. And I said, wow, I didn't know it would go that much, or I didn't know, you know, that parameter would change that much.
Yeah.
And it does slightly, you know, it does change your box design, not drastically. You know, it doesn't make it, you know, half as big or half as large, but it changes it.
Yeah.
And everyone would rather use real world specifications than, you know, than small signal, I think now. And there's really a following of that. Everyone will ask us for, you know, as a Dayton Audio driver designer, they all want to know what the Clipple, what the BL was. They want to, you know, they're all getting familiar with large signal parameters. And this is one way for them to either verify that the Dayton Audio driver or the driver that they have is actually what they say they have.
Yeah, kind of proving the spec sheet.
Right.
Yeah, or you know, revealing you know what's on the spec sheet. So who all should use the DATS LA?
Well, like I said, every driver designer, that's for certain. Any serious audiophile who's a speaker builder, I think, could use this. And anybody interested in just driver design in general, like just how parameters, you know, change, and the behavior of a loudspeaker when it's under duress or under, you know, excursion, you know, as it's being excurred farther and farther and has more voltage input, things start changing pretty dramatically.
Yeah.
And then you wouldn't, you know, you would think so, and it makes sense, you know, as a you know, as a driver designer myself, it makes sense, but you didn't realize when you see it on a graph that, wow, it makes a big difference. You start losing all your BL, you know, as you get out of the gap. Right. You push that speaker far enough.
Yeah, because again, it curves out, so you know, it's that magnetic force is, you know, kind of peeling away from the coil.
Exactly.
Oh. Well, I'd say I kind of learned a lot about the DATS LA. Is there anything I missed from your perspective as far as, you know, the whole reason I wanted to ask you these questions is that I'm sure I'm not the only person that has questions about the DATS LA.
Yeah, I think some people get confused with the DATS V3 like they already have one.
Yeah.
No, this is a totally different animal. It took us a long time to you know, to develop this product. I think, and the beauty of it is a customer will ask for something, and if it seems reasonable, I'll ask John.
So constant tweaking on the software,
and that's what keeps
around. Yeah,
and that's the same way with the DATS LA. It's not going anywhere. It's only going to get better.
Yeah, that's great.
If you see anything that it could be improved, it's only going to get better because we're all.
I know Dayton Audio as you know, the DATS V3s, you know, really well received, and you know, hopefully you know, they get a lot of love on the DATS LA too.
That's what we're hoping.
Yeah, well, great. Well, thank you, Brian, for
thank you,
explaining all that to me today, and thank you all for joining.
Thank you.